Okay, so we're just at the top of page 143, as you can see. Okay, 143. You need to know these diagrams. Okay, you got A, B, and C. And again, these are very, very good. They show a kind of a 3D sketch and also, excuse me, a little diagram looking down from above. That's what these are. Okay, they're called a plan diagram. Okay, so the development of a stack blah, 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 is photographed. Okay, we'll look at that in a second, and we'll go on to blowholes in a second. So what we have, again, look, headlands sticking out into the sea. If you look at it, okay, the waves curve around the headland and attack it on all sides, just like my arrows earlier. So the headland is getting eroded on both sides. Where you get a little cave forming on both sides, okay, caves developing opposite each other, they'll eventually meet in the middle. Alright? So look what happens. Okay, the wave attack continues. The two caves ultimately join up and an arch forms. So an arch between these areas. Alright? And you can see it in here. You can see right through the whole headland. This arch is already done. There's new caves being eroded to make a second arch. Finally then, the arch collapses and a stack results. So now you can see, alright, where our first arch was, the roof's collapsed, so you got this little stack sticking out. We got a new arch in here from the second cave. Okay, so that's all it is. A cave becomes an arch, becomes a stack, becomes a stump. Okay, so to look at our stumps very quickly. Alright, now this is quite a dramatic example, and I must say the coastal landforms are hugely dramatic, like sea arches and stacks and stumps and stuff are very impressive. So what I want is, this is a coastline in Scotland. Okay, now the seas can be very rough in Scotland, so there's a lot of erosion. In the background you can see our cliffs. Okay, I've drawn that in, and there's your wave cut platform, the flat bit at the bottom. We've actually got a small archway down here, which you may not have seen. Okay, and now what we have is these stacks. You can see they're not connected anymore, but these are a strange shape, because usually you would expect the bottom of them to be narrower due to that's where the erosion occurs. But up here, Scotland gets huge amounts of rain and wind, so the tops of the stacks are being eroded away by weathering. Okay, we've looked at weathering before. Alright, so remember, these were part of the headland, so they're actually resistant rocks. So these, at one time, the land would have come up like this and gone straight over, but this bit here has now disappeared. It's collapsed into the sea. Okay, so that's just an example of some stacks there. What we're going to do is we're going to move on to looking at something called blowholes and geos. Okay, and we look at a little diagram on the next page, but some stuff to highlight first. A blowhole and geo. Okay, some caves develop in well jointed rocks, so again, these are dependent on the geology. Okay. Joints and bedding planes are opened under wave attack, hydraulic action, okay, both by abrasion and hydraulic action. So again, always the same types of erosion cause all of these landforms. They're all caused by erosion. Let's jump on to the next page. Okay, so I find these to be the easiest diagrams to look at because this side view is a bit confusing. But again, what you have is, when you get a cave developed, okay, it's eroded away, the water can go in through the cave. Alright, and sometimes a little area like here, okay, collapses. Now, not the whole roof of the cave collapses like in our definition earlier, just a little portion of it, because when the water is pushed in here, okay, it can smack up against the ceiling of the cave, smack up, and actually start to erode. So it erodes in first, and then it can erode up. And if this bit collapses, you get a blowhole. Alright, and then sometimes, if the waves are strong enough, you'll get a spout of water coming out. Okay. Now, if the next bit collapses, this bit between the blowhole and the entrance to the cave, it forms a geo. Okay, so you're left with this kind of narrow gap in here. So there would have been a cave just here, and a blowhole just here, and the roof in between has collapsed. That's all it is. Again, gravity and erosion. Alright, when water goes into the caves here, you have to remember, huge waves are forced into a small area, so they just smack against the roof, the ceilings, the walls, everything, and cause a lot of damage, or very rapid erosion. Alright, that's your blowhole and geo formation. We're not finished yet. So what we'd said is, sometimes once the cave is formed, if there's certain weaknesses and joints that the water can expose, okay? Sometimes a joint extends from the roof of the cave, all right? In time, the joint may be opened right up to the top of the cliff. When this happens, a blowhole is formed, all right? So again, if you've got one of those vertical joints running down through the geology, so if you've got vertical joints and bedding planes, remember when we looked at those words? So if you've got one that runs the whole way down, the water can come in and up. All right. The roof of the cave ultimately collapses and a long, narrow inlet called a geo is formed. So we've looked at that in both diagrams just there. Okay. They are our last two erosional landforms. All right. So headlands and bays, caves, arches, stacks, stumps, blowholes, and geos. They are all erosional. They're not formed by any deposition. Okay. Now the second process that occurs along the coast is transportation. Right? There's erosion, there's transportation, and deposition. Remember we said the ocean erodes the coast, it breaks it up, then it transports all that little material, and then it deposits it somewhere else. Okay? Luckily there's only one method of transportation. So let's have a little look. Alright, right down the bottom of page 144. How waves transport material. Now again, I've put New Outer World, page 302, so you can find another diagram just there. You do need to have a clear understanding of this, alright? So, some of the load transported by waves comes from rivers entering the sea. So rivers, as they enter the sea, they dump lots of sediment that they've eroded as they travel over land. Some comes from mass movements of cliffs. We've talked about our slumping and rock slides and mud flows and all that. A lot of that falls into the ocean. Alright? And the rest comes from wave erosion. So as the waves break up the headlands and create our bays and our caves and our arches, all of that rock and sediment has to get moved somewhere else. Okay? The load consists of mud, sand, and shingle. Shingle is small little stones. So what happens? When waves break, the swash moves obliquely, alright, up the beach. It doesn't move at a right angle or parallel to the beach, it moves at an angle. We'll look at that in a bit more detail in a few minutes. So the swash goes up at an angle, up the beach. It brings the sediment up at an angle. The backwash runs back down the steepest slope, back down the beach. The quickest and easiest route is what I usually say. Okay, so this is at a right angle or a straight line. So the swash will go up at an angle because the waves break at an angle to the coast. It's very rare you get waves moving perfectly straight onto the coast, onto the beach. Okay, so the swash comes in at an angle, and then the backwash will go straight back into the sea. Swash pushes material up the beach diagonally, and the backwash of larger waves drags some of this material back down the beach to the sea. The swash from the next breaking wave pushes some of the material back up the beach, and the process continues. Alright, this is called longshore drift. So you need to know that. Now what we're going to do is, I'm going to show you a diagram now, okay? And we're also going to do just a very short little written paragraph, so we have a simpler explanation of how this occurs. Alright? So, okay, so the first diagram we're going to draw, I've done mine very big and very clear, so it's simple and easy to read, okay? You've got beach and sea. This black line is the coastline, that's where the beach starts. Okay, now longshore drift, there's two things. Prevailing wind, we know wind controls all waves, and the second thing is the waves themselves. So the prevailing wind is blowing at this angle. Okay, if it's blowing at that angle, then the waves will travel at that angle. So waves approach the beach at an angle not 90 degrees. They very rarely approach perfectly on. Okay, think about the next time you're at the sea. So what happens is, if the waves approach like this, the swash, okay, the little red dots are the sediment, the swash comes up the beach at an angle, and the backwash takes the easiest and fastest route back, okay, straight down the beach. It doesn't go at an angle. The swash is forced up this way, and then the backwash straight back, the quickest and easiest route. Okay, so sketch that down nice and quick, and I'll show you the second one in just a moment. Okay, so very quickly then, our second diagram is exactly the same again. Beach, sea, prevailing wind coming in at an angle. Here are my waves, the blue bits, okay? Then I've just essentially zoomed out a bit. Sediment has moved in a zigzag pattern along the beach. Alright, swash comes up at an angle, backwash straight down. Swash, backwash, swash, backwash. And that's all it is. It just keeps moving like this. And eventually it'll stop and deposit the material somewhere else. Okay, so get those two sketches done. That is your longshore drift done.